All right, here is another kind of quick and dirty lesson about how to reduce air pollutants. So, reducing air pollution. So, how could we reduce air pollution? Well, one thing is to set up regulations from the government that kind of set up these standards that dictate how much you can pollute or how much you can emit into the air. So, the Environmental Protection Agency does. Kind of set a lot of these regulations. One example is the CAFE standards or corporate average fuel economy standards, which regulate basically how many miles per gallon a vehicle can get. So they set a minimum standard, and every vehicle that is produced or sold in the United States as a new vehicle has to meet those standards. And the goal has been to raise that gradually over the years so that cars and trucks and any sort of large vehicles can all get more miles per gallon so that less gasoline is used. So this lowers the amount of gasoline used, which can reduce the emission of VOCs, um, CO2, NOx's, a lot of those chemicals. Then there's conservation practices, so you can reduce your electricity usage or automobile usage, which can help decrease pollutant emissions. And then there's alternative fuels, so you could use renewable energy sources that don't involve combustion and therefore don't release particulates and some of those other combustion products into the air. There are a number of technologies that can help reduce air pollution. So, coal burning power plants have two major ways that they reduce air pollution, and that is they use scrubbers and electrostatic precipitators. Now, a scrubber is a kind of general term for something that whose fancy name is flue gas desulfurization. Flue is basically like your chimney or smokestack. So, flue gas is the smoke coming out. And desulfurization means you're desulfurizing, you're taking out sulfur. So, what it does is it removes sulfur dioxide from whatever exhaust is being released from the burning of coal by spraying what is a wet slurry, so kind of a mix of crushed up limestone, into a chamber where you're pumping the gas. And the thing about that is limestone reacts, or the calcium in the limestone reacts with the SO2, makes something solid that you can then get rid of, and then you can release cleaner air, cleaner um, exhaust into the environment. Then to remove particulate matter, you can use electrostatic precipitators. Basically, they give particles a charge, so they have an electric current. They charge up particles, which they then pass through. Keep in mind, this is all in air. They pass through an area with some charged collector plates, which will electrically attract those now charged particulate matter. And so then those collected particles can be taken out from the collector plates as either a dry material or they can be washed away with water. The point of that is to say that, okay, if they're washed away with water, that'll make a slurry. If they're collected as dry material, that'll make some sort of powder or substance that then has to be disposed of somewhere. So, this is flue gas desulfurization or scrubbing. So, you take your flue gas from whatever you were burning. You're going to add oxygen, or, well, it's got SO2 and SOXs. You're gonna pump it into this chamber. Sorry, it's SO2 and oxygen. Um, and then what's gonna happen is you have this mister that sprays in water that hopefully will dissolve the SO2 in the air. And then as it falls, it's going to fall into this pit with a limestone slurry or some sort of calcium containing compound, which will then react with the sulfur oxides to produce a compound or a material called gypsum. Gypsum has a number of uses, so it can be then sold or used elsewhere. And then theoretically, you have clean gas that's being released. And then, as far as we talked about in class, the fact that when you pump gasoline, some vapors escape. The Nozzles that we use at the gas station to pump gas are already designed to try to reduce the fumes that are escaping from the car during fueling. So remember, gasoline is very volatile, meaning it will evaporate fairly easily. So, sitting in your gas tank right now, unless it's completely full, is a mixture of vapor and liquid. Now, in an old school nozzle, if you would pour in the liquid, the vapor would come out because there's only so much volume in there. Now, these systems are designed so that when they pour liquid gas into your tank, any vapor that's in your tank goes back up into the nozzle and then can go back into this kind of gas reservoir that is in gas stations. So that means that not only is the vapor not released into the air, so it's not contributing to VOCs, etc. It's also going to then hopefully condense and be reusable. Then another automobile related device is a catalytic converter, which should be in all cars. What they basically do is they are going to use some sort of catalyst. Catalyst causes chemical reactions. If you remember in biology, it's kind of like an enzyme. So it's going to cause some of the gases that are in the exhaust, like hydrocarbons, carbon monoxide, and nitrogen oxides, to react and form less harmful molecules. So carbon monoxide would be converted to CO2. Those nitrogen oxides could be converted into nitrogen gas and oxygen gas, and then also water as well. So that way they can be released and have less of an impact on the environment than, say, releasing NOx's and hydrocarbons. Then there are scrubbers, wet and dry scrubbers, that can be used in factories or other buildings that are producing some sort of exhaust. So I have found a cool diagram that shows you the difference between wet scrubbers and dry scrubbers, as well as electrostatic precipitators, which we talked about with coal-fired power plants, so that you can see kind of how they work. So my bad. You have a wet scrubber. It's going to involve water. So water is going to spray down. You have the gas coming in that has your contaminants or whatever. You spray water. Hopefully, those get dissolved out of the atmosphere and then they collect in this kind of fraction. And this fraction can then isolate the pollutants, which you then have to dispose of. Another way is you have gas with contaminants coming in a dry scrubber, which involves no water. It has to go through some sort of, I'm assuming, solid or maybe particulate media material, something that will absorb some of the harmful compounds or at least block their passage. And then the gas, as it passes through, is released is cleaner. And then an electrostatic precipitator. If you remember, I said you take an electrical current, you charge your particles. So these are the gas contaminants coming in. They acquire a charge, positive or negative, and they are going to be attracted now to these collector plates. And I happened to, let's see, the collector plates, it seems here, are positive. So anything that's negative is going to be attracted to the collector plate. Anything that's positive is going to be attracted here. And then those particles will not be in the air, so you can release clean gas. And this is my very optimistic Bitmoji because honestly, the problem is not solved. Otherwise, we wouldn't be learning about it, but I mean, I guess every bit helps.